Hey everybody! Today's practice problem comes from Economics Principles and Applications by Robert Hall and Mark Lieberman. We're going to be working from the 6th edition, and the problem we're going to be doing is Chapter 3, Problem number 2. The problem reads, discuss and illustrate with a graph how each of the following events, cateris paribus, ceteris paribus, I've heard it pronounced a number of different ways, regardless of how it's pronounced, all else being equal, or all else held constant is what that means, how all of these things will affect the market for coffee. So what we need to do is we need to start by drawing a market diagram for our coffee market. And we can do that by just drawing some simple axes like this. And remember, when we're drawing our market diagram, we always have quantity on the x-axis. Some textbooks are very particular and they say, oh, well, when we're talking about market quantity, we're using a capital Q. And when we're talking about the quantity for an individual consumer or the quantity produced by an individual firm, we use a lowercase q. So I'll just err on the side of caution here and put a capital Q here. And then on the vertical axis, we put price. So all of our diagrams are going to start with this very basic setup where we have price on the vertical axis and market quantity on the horizontal axis. Part A of the problem says, a blight on coffee plants kills off much of the Brazilian crop. So we want to think about how that affects our supply and demand diagram. And we can start by just drawing a basic supply and demand curve where we know that demand curves look something like this, and supply curves look something like this. I had a professor one time, he was trying to give students a mnemonic to help them remember which one was which. So if it helps, you can think of the phrase, supply up to the sky, demand down to the land. It's a little cheesy, but people like to remember things, and it's a helpful way to remember which one's which in case for whatever reason you ever forget. So we can start with these curves, and we generally have 3 steps. We want to identify what changed in our market, whether we are affecting supply, affecting demand, or both. We want to understand which way something is shifting, and then we want to move from the old equilibrium, which is the old intersection of price and quantity here, to the new equilibrium, and understand what is happening to equilibrium prices and quantities in the process. So we've got this blight, and we can go through and think about the determinants of supply and demand. It's helpful to be able to have a mental list of those. So I could say, for example, oh, the determinants of supply are the price of the firm's output, the price of the other things that the firm could make with those resources, input prices, technology, expectations, number of sellers, those sorts of things are all determinants of supply. For determinants of demand, we want to be able to rattle off a similar list and say, oh, price, income, prices of related goods, taste, expectation, number of buyers, things like that. And if we have that mental list, it's really helpful because then we can just go through for any scenario and say, okay, is it this, is it this, is it this, and so on and so forth. So in this particular instance, we've got this bad weather. And we think about what determinant of supply or demand that could possibly be. Well, the bad weather that's killing off the crop doesn't change how much consumers want coffee. You know, we still need to be caffeinated the same amount as we did before. But what it is affecting is it's affecting the supply of coffee. And if we were to think about what determinant of supply it affects, in a very technical sense, it affects technology. Because if we have this weather killing off part of the crop, then with the given amount of inputs that we put into making coffee, we're getting less stuff out than we did before. So it's sort of a contrived way to think about that. But in any case, regardless of how we think about it, this is obviously going to be a decrease in supply because part of our crop was destroyed. And a decrease in supply looks like something similar to this here. So what you can see here, and you can either think of this as, we like to think of things as decreases as shifts to the left and increases as shifts to the right, because that way our shifts are consistent regardless of whether we're talking about supply or demand. But technically speaking, you could also think of this as a shift up of the supply curve. And that's an interesting way to think about it, because as we go on further in the course, we'll see that the supply curve represents a marginal cost of production. And hey, if some of your output got destroyed, it's essentially more expensive than it was before to produce output. So your cost increased, so it makes sense that your supply curve would shift up. Regardless of how you think about it, you're going to get a picture that looks something like this. And we can identify the original equilibrium here. If we were to call this Q1 for original, and then star, we usually use stars to represent equilibria, technically speaking. So we'd be here at Q1 star and P1 star. And then after this reduction in supply, we would end up at some market quantity Q2 star here and a price P2 star here. So what we would see in our equilibrium is that we've moved up and to the left, or we'd see that this reduction in supply is pushing prices up. And the fact that the price got pushed up means that we're going to be transacting fewer units than we were before. And an interesting thing to think about here is that that has to be the case, because if the price didn't adjust and we tried to keep the price at P1, there wouldn't be enough to go around. That at this price P1, our demand is still out here, and our new supply is here. And we would actually have a shortage at this price. And we know that shortages push prices up, so it's not surprising that we would get upward pressure on prices until supply and demand are back in balance. Now that we've gone through that exercise in a fairly typical fashion, I'm going to level with you a little bit here. So basically what we described in this scenario with the bad weather is that the bad weather happened after the producers had decided how much crop to plant. So it's a little bit strange to say, oh, well, the supply curve just shifts to the left and higher prices can still somehow induce more coffee to exist. When in reality, the producers made a production decision, the weather was worse than expected, and then regardless of the price, they only have so much coffee around to sell. Now, that may or may not literally be true. Maybe they had coffee in reserves that they could pull out and sell if it was economically beneficial to do so, and so on and so forth. But if we were to consider very literally this scenario of the bad weather happening after a production decision was made, we could still do this analysis and we would still get to the same result, but the curves would look a little bit different. So we would still have a normal looking demand curve like this. But we would see that once we've made a production decision, the amount that we're supplying in the market is no longer responsive to price. So we would have said, oh, well, we made a production decision and we decided we were just going to produce this quantity here. And then the bad weather made it so we didn't get as much out as we thought we were going to. So we would just have a supply curve that's what is known as perfectly inelastic or perfectly unresponsive to price. So this would just look a little bit different, but the analysis would still be the same. That we would still be going from this equilibrium here to this equilibrium here. So we would still see that we were getting an increase in equilibrium price and a reduction in equilibrium quantity. It would just be the case that these curves look a little bit different. Part B of the question asks us to draw the market for coffee if the price of tea declines. So we want to think about how that affects the market for coffee. So again, we want to start by drawing just our regular supply curve like this and our demand curve like this. And then we want to think about what determinant of supply or demand the price of tea declining falls under. So supply, the price of tea declining doesn't really affect the producer's ability to produce coffee, right? Because we're not going to assume, for example, that the producers have the option to either make coffee or tea. They take different resources, so I don't really think that that's a reasonable assumption to make. What I do think, and maybe some people argue with me on this, but what I do think is that coffee and tea are substitute goods. That we want something, it has to have caffeine, we're tired, we want a liquid, and we're either going to have coffee or tea. That they're things that are consumed instead of one another. They're not things that are consumed together, really. And that's the economic definition of substitutes. More formally, the economic definition of a substitute is if two goods are substitutes, when the price of one of them goes up, the demand for the other one goes up. So if Pepsi gets more expensive, the demand for Coke goes up. Please don't argue with me on whether Coke and Pepsi are substitutes. Conversely, if the price of Pepsi goes down, Pepsi goes on sale, some people are going to switch over from Coke to Pepsi, and the demand for Coke is going to decrease. So here, if coffee and tea are substitutes, then that means that the decrease in the price of tea is going to make tea look more attractive. So some people are going to switch over to tea, and it's actually going to decrease the demand for coffee. So what we're going to see is a decrease in the demand for coffee, which again, decreases can always be thought of as shifts to the left on the quantity axis, right? You could also notice here, if you really wanted to, you don't have to, that a decrease in demand, you can also think of it as a shift downward. And what this means is when there's a decrease in demand, consumers aren't willing to pay as much for a given level of quantity as they were before. So we could think of this as for this level of quantity, consumers used to be willing to pay this much, now they're only willing to pay this much. So there are two different interpretations of this shift. Both of them can be helpful depending on the context. Regardless, we get something that looks like this, and we see an equilibrium that moves from this intersection of supply and demand to this intersection of supply and demand. And we can label this, again, with our asterisks for equilibrium prices and quantities. We could call this P1 star and call this Q1 star, and then we could call this P2 star and Q2 star. And we would see that we're getting something that's moving down and to the left. So we're getting a decrease in quantity bought and sold of coffee and a decrease in the price of coffee. Essentially what this means is that coffee producers are saying, oh crap, tea went on sale, consumers are switching over, now we have all this coffee left over. Well, what do? We have all this inventory of coffee. Let's put the coffee on sale. Oh, and by the way, if we have the chance to make production decisions again and we realize that consumers have switched over to tea, let's not make as much coffee next time. And you can see this on the diagram as well. Though we can say, well, what happens if the price does not adjust? If the price doesn't adjust and the market thinks that the equilibrium price is still P1, they're going to keep producing as much as they were before. Because there's a bunch of firms coming together, that you don't have one firm seeing the entire market by itself. And we would see at this price that the firms would come together to produce this much here, because that's where the supply curve is. But then the new demand curve is here, so at the old price we'd actually have a surplus. And we said that surpluses drive prices down, which is how we get to this point here, that this lower price is the thing that resolves or mitigates this surplus. Part C of the question asks us to describe what happens to the market for coffee if coffee workers organize themselves into a union and gain higher wages. So again, we start with our basic supply and demand diagram. Supply up, demand down, quantity on the horizontal axis, price on the vertical axis. And then we think about what factor of supply or demand, or what determinant of supply or demand is affected by this unionization, and more importantly, the higher wages for the employees that make coffee. So we can think about, on one hand, unless we have a reason to believe that the people who buy coffee specifically care about how much the workers are paid, in reality, we could make somewhat of a convincing story that, oh, well, if the customers know that the coffee workers are getting paid more, they'll feel better about buying coffee, they'll want to buy more coffee, and so on and so forth. We could make that argument, but it's somewhat of a speculative argument, so we don't know whether that holds in practice or not. So let's start with a more basic effect and talk about that here. So if we make the assumption that the higher wages for the coffee workers doesn't really affect how much consumers want the coffee, then it stands to reason that if this is going to affect the market for coffee, it's going to affect the supply of coffee. And in fact, one of the determinants of supply is input prices, or equivalently factor prices. The prices are the factors of production. And workers are in fact one factor of production. So an increase in their wages is going to be an increase in an input price. So we know that, we could just memorize that when input prices go up, supply decreases. Or we could think this through logically to remind us. We could say, well, if the input price goes up, so workers got more expensive, for example, it's less attractive to produce. And hey, if it's less attractive to produce, then suppliers are going to produce less than they did before. It's sort of an intuitive way of remembering which direction everything goes. That in general, if you make something less attractive to produce, producers supply less of it. If you make something more attractive to produce, producers supply more of it. So here, this increase in the input price is going to lead to a reduction in supply. And a reduction in supply, again, looks like this here. We could either literally think about it as a shift to the left on the quantity axis, or we could recognize that supply represents cost, and the higher wages result in higher cost to the producer. So it's not surprising that the supply curve can also be viewed as shifting up. So we check this out, and we're like, oh, okay. Now we just have to identify the old and the new equilibrium and compare. So what we're seeing here looks pretty much like what we saw with the weather example. That we have something, the shifting supply to the left. So in a very similar fashion, our equilibrium is moving up and to the left. So what we're going to see is a decrease in equilibrium quantity, as shown here, again, Q1 and Q2 star, and an increase in equilibrium price from P1 star to P2 star. And again, we can think about why this is, and again, this reduction in supply, if we didn't change the price, was going to cause a shortage. And that shortage would push market prices up to meet this new equilibrium here. Part D of the question asks us to describe what would happen to this market if coffee is shown to cause cancer in laboratory rats. So we can think about what's going on with the market here. And again, we want to think about what factor or what determinant of supply or demand could possibly be affected. We could go through the determinants of supply, got the price of the firm's output, the price of whatever firms could be doing with those resources, input prices, technology, expectations, number of sellers. And we could try to make a case for why this cancer in lab rats thing would affect one of those determinants. And it's not really clear. The best I could do is to make a tenuous case that, well, if the coffee causes cancer in lab rats, then maybe there are going to be more coffee lawsuits, and then there are going to be more costs on coffee production, and so on and so forth. But that's a tenuous at best argument. And B, it's unclear whether that would actually shift the supply curve or whether it would just change a fixed cost of producing coffee. So rather than making, those three levels of logical jumps, let's do what the problem probably intended for us to do and think about the demand side instead. So we can think about, just as a consumer, if you were told, hey, by the way, coffee causes cancer, well, if you believed that if it caused cancer in lab rats, it would cause cancer in you, how would you think about your demand for coffee? I don't know about you, but I would probably demand less coffee, right? And we can think about what determinant of demand that might fall under. And we say, well, the price of coffee didn't change by itself. Our income didn't change. Price of a related good didn't change. really what changed was our fundamental taste for coffee, right? We said that taste is sort of that catch-all category where it just represents how much you fundamentally like something. And if something is going to give me cancer, I fundamentally like it less. I don't know about you. So the most reasonable thing to guess is going to happen in this market is that we're going to get a decrease in tastes for coffee, which is going to be a decrease in demand. So we're most likely going to see something that looks like this. So this is going to look pretty similar to the decrease in demand example that we did before. That we're going to see a movement from this equilibrium here to this equilibrium here. And again, we could think of our demand decrease very simply as a decrease or a shift to the left along the quantity axis. Or we could think of this as a shift down where consumers are not willing to pay as much for coffee as they were before. I tend to be willing to pay less for things that cause me cancer, so that kind of makes sense. And we could just go through and label the old and new equilibrium again. We'd have Q1 star, Q2 star, P1 star, and P2 star. So again, at this old price, we would have a surplus, so we'd have too much coffee produced, and producers would have to put that coffee on sale and start producing less of it in order to bring supply and demand back in balance at this new lower level of quantity. Lastly, the question asks us to analyze what happens in the market for coffee if coffee prices are expected to rise rapidly in the near future. So we can think about what's going on here. And again, we start with our basic diagram of supply and demand, and then we think about whether this scenario affects the supply of coffee, the demand for coffee, or both. So we can start thinking about, on the supply side, we talk about the role that expectations play in the level supplied today. And for producers, if they expected the price of their output to be higher in the future, then if it was physically possible, they would want to hold back some of their supply today in order to sell it at the higher price in the future, right? So what would actually happen if this was possible with coffee was that the suppliers would say, well, I don't want to supply as much now because I want to hold it to sell at the higher price later, and that would actually be a reduction in supply. And that's most reasonably thought of literally as a shift to the left. That at any given price, suppliers are willing to supply less in the market than they were before. Now, of course, we could think about, is it reasonable to stockpile coffee? Does it go bad? Is it not as high quality if you wait and sell it later rather than having it be fresh? I don't know. But for the purposes of this exercise, let's just say that coffee is something that could be stockpiled. Firms are going to want to do that to sell it at a higher price later. That said, if you were a consumer, and we're talking coffee here, so I'm going to be picky about coffee and point out that you shouldn't have stale coffee. It doesn't taste as good. But it's not like it actually goes bad very quickly. It's not yogurt. It's not milk, right? So you might have some degradation in quality. But we can think about if you were told that coffee was going to get really expensive tomorrow, you'd probably stock up on coffee, right? So what we would see from the demand side, because expectations of future prices is a determinant of both supply and demand, from the demand side, you'd probably also see an increase because consumers would be stockpiling coffee to try to avoid the price increase. So we would see something that looks something like this, right? That at any given current price, consumers are demanding that they more than they were before because they're worried that they're not going to be able to get it at this price tomorrow. So this is an interesting example because we have two things moving around. And we can still compare the old equilibrium to the new equilibrium, but we have to be really careful when we do that. But we could start by looking at this graphically. We can see that the old equilibrium is just here, and the new equilibrium is here. And we could try to label these. And I could say, okay, this is Q1 star, and this is P1 star. And then I have a P2 star that's up here. And I have a Q2 star that looks like it's basically on top of this Q1 star. And then we can say, well, wait a minute. Do these effects literally cancel each other out, or is something else going on? And this is where we want to be careful. Because when we have multiple curves shifting at the same time, we're likely to get some ambiguity in what happens to price and quantity. And here's why. So we could analyze each of these effects separately and then put them together. So the decrease in supply is something that we talked about in a couple of earlier examples. And we said when we have a decrease in supply, that that's going to lead to our equilibrium price going up and our equilibrium quantity going down. If we were to think about the results of this demand increase, if we were to think about what would happen if we only had this demand increase, if we only had the demand increase, we'd go from this original equilibrium to this point here. So we'd be going up and to the right. So the effect of the demand increase by itself is to raise equilibrium prices and also to raise equilibrium quantities. So we can think about what the overall effect is by just putting these two things together. And even though we only have qualitative changes, we can at least draw some conclusions. And I can see here we have two price increases. Those by definition have to combine for an overall increase. So overall, we could say that these changes are pushing up the price of coffee today. Which is an interesting finding, but not entirely surprising, that if everybody agrees that prices are going to go up tomorrow, that's going to filter through and make prices actually go up today. On the quantity side, however, we're not really sure what's going on, because I have a qualitative decrease and a qualitative increase. To know whether that's an overall increase or decrease, I would need to know which of these was bigger. And I don't have that information. So actually, I'm not sure what happens to the equilibrium quantity in this market. To illustrate this point more clearly, I've drawn two diagrams to help us out here. So if we look at the diagram on the left, we still have a decrease in supply and an increase in demand, but this time I made the decrease in supply much bigger than the increase in demand. And what we can see in this case is that we pretty clearly get an overall decrease in the quantity transacted in this market. And that makes sense because if the decrease in supply is much bigger, then the force lowering the quantity in the market is going to be stronger than the force raising the quantity in the market, and we're going to get an overall decrease. However, if we think about the opposite scenario, if we think about a scenario in which the decrease in supply is small compared to the increase in demand, we're going to get the opposite result, as you can see here. Here you can see pretty clearly that we're getting an overall increase in quantity transacted in this market. And that's simply because the force that is lowering quantity, that being the decrease in supply, is less strong than the force that is increasing the quantity in the market, that being the increase in demand. So if you draw curve shifts that are of different magnitudes, it's not going to look like the old equilibrium is right on top of the new one. And you want to make sure that you're not making assumptions about what's going to happen when the actual behavior is in fact ambiguous. But what we do notice here is that in this particular example, we're always getting an increase in equilibrium price. But you want to be careful because depending on how the curves are shifting, it may be the case that our change in price is well defined and our change in quantity is ambiguous, as we have here. Or it could be the case that our change in quantity is well defined and our change in price is ambiguous. So you want to make sure that you don't assume one way or the other as soon as you see multiple curves shifting.